We're going to take a look at the case where you're not necessarily looking for the highest value or the lowest value. You want somewhere closer to some specific number. Like for example, temperature. You might not want the hottest place ever or the coldest place, but maybe you want somewhere that's like pretty close to 80 degrees, right? So before you start this, just double check and make sure if you scroll that these pieces are frozen all the way up to minimum. So what we can do is we can do view, freeze, row 4. Okay, so now when I scroll it and I have these values, it's not going to mess things up. All right, so how do I find out how far away something is from, let's say, here I have a median age data. And let's imagine that I wanted to hang out with people that were 30 years old, or at least pretty close to 30. So I could look at the average age and subtract it from 30. So let me do it from low to high. Here we go. Okay. So let's say I did equals this number, 30 minus this number. Okay. And you could do that. But the problem is, on the higher side, you end up with these negative numbers, and that can cause problems. So instead of just subtracting 30 minus that, we're going to do it slightly differently. We're going to subtract them, but then we're going to take the absolute value. So I'm going to start off equals absolute value. ABS, when you type in abs, it comes up abs, and that's where I'm going to do 30 minus whatever's in this cell. If I was 25 and I want to hang out with the 25-year-olds, I would do 25 minus whatever this part is here. Actually, I'm 40, so it's a little bit off. All right, autofill, yeah, sounds good. Let's double check. Okay, 24 is 6 away from 30. All right, sounds good. What about 30? Is there anybody that's actually 30? Okay. Yeah, these two cities are exactly 30, and we got it. 0. Okay. So the thing is that you, if you're looking for the average age to be about 30, you actually want like these cities, right, that have a low number. So we want to have it so that if the number comes out low, that it's a good thing, that it will give us a high score. So the way you can convert that, this is also the same thing we did for crime. Like you want low crime. Low crime should give you a high score. Okay, low difference from 30 should give you a high score. The way you do it is you're basically going to flip. Here it is. So if you want a low score to be a good thing and give you a high score, you basically flip the number. So I would take equals 1 divided by whatever that number is. Okay. Autofill sounds good to me. There it is. So let's see. If I'm 30, ooh. So 30.1 average age is actually the highest score. Let me see. Z through A. Okay. Yeah, so the ones that are really close to 30 should give you a high score. This one's a little bit like an error message. It's because if you divide by 0, it's not really mathematically, it doesn't make sense to divide by 0. You get an error. It's impossible. So what we want to do is we just want to make sure that these that are exactly on 30 should get a higher score than these ones. So previously the highest score was 10. Let's just make this 11. All right. Boom. There you go. Sounds good. All right. Now, like in our other data, this number could be kind of weird if you're comparing it with other variables. Looks like the highest is 10. Like if I compared it to the average rent and I average, I try to make a score based on that, it's not even going to consider what's going on with this variable. It'll just look at the big number of the rent. So I need to change everything so it's a score between 1 and 100. And we do that using this thing called normalizing. And this formula that we have here basically takes your data and changes it to a scale of 1 to 100 or 0 to 100. Okay. So it's kind of a funky looking formula, but it uses the minimum, the maximum, and the minimum here of this column. So like the lowest value which is probably 0. Oops, let me do A to Z. Oh, 0.5, because that's the lowest score, and then the high score. So you could like manually type that in, but you'd have to do that 500 times. So let's not do that. So I'm going to need to use the min and the max. Let's go ahead and do equals. Okay, that's the max. You know, I'm going to switch these because, no, it's okay. This is the max. All right, here's the min. Okay. All right, so let's go ahead and put in this formula. So always start with the equals, and then it's whatever's in the cell minus whatever the smallest value is divided by whatever is the highest value minus the min, that's the smallest value in this column, times 100. Shift 8 is times 100. There you go. That's the one that's got like the best outcome. It's right at 30. That should get 100%, like a full score. Oh, something's wrong. Oh, you know what? So when you do this formula, you see there's like these dollar signs. You need to put that in here for the min, the max, and the min. You have to put little dollar signs. Okay, E3 and E4. Okay, now it's okay. And the reason why you put these little dollar signs here is because you want it to always go to this exact cell for the max value and the min value. If you don't, then as you scroll down to more and more cities, it's going to pick that min and max number, like it's going to shift that number down too. So it'll pick out the 5 or the 3 or whatever. So you'll get some incorrect amounts. Okay, but this should work. So it looks like the best one, the one that has people closest to 30, is Far in Clarksville. The one that is farthest from 30 is Palm Coast and Largo, probably because it's like an aged population. Aged. Okay. All right, so these would be like your cities. Okay. So, I mean, if that's your only thing you're considering for that category, you could use this score, 1 through 100. But let's say that the person who made this wanted to consider 2 things. Let's say they wanted to consider the median age being close to 30, and let's say they were veterans and wanted to know, how many other veterans, female veterans between 18 and 34 there'd be. And so I chose this one because it's kind of a random one, but I have data about the count. In order to compare it, like if you just do the count, New York's always going to win because it's a huge city. Well, probably. So what you can do instead is, like we did with the crime, you can divide it by the population. Right? I want to see the percentage. This number of veterans divided by that piece. Yeah, we'll apply it through the whole thing. Okay, so that is the number of female veterans. Just like we had here, we can normalize that formula. So right now, if I was to combine these two, these numbers are a lot smaller. They basically wouldn't even be weighted in this problem. So I'm going to normalize it. Same formula here. I need the min and the max. Sorry, this is the max, and this is the min in the way I set it up. So equals the max of I5 to I. That will take everything in this I column and the min. Okay, let's go from I5. That means start here, semicolon, and yeah, sure, this sounds good. 504. Cool. The lowest value is 0. Female veterans in that age group. The highest one is 0.37. Sounds good. So now I can do this formula. It's whatever's in that block minus the smallest value divided by whatever the biggest value is in that column minus the smallest value times 100. Oops. Enter. Oh, right. Remember, we have to put the dollar signs in there. Dollar sign, dollar sign. There we go. And that's how you do it. Chaza. Okay. Let me scroll this through. Okay, so we got a score for like the age being close to 30. And we got another score for, did this multiply by 100 times 100? Yeah, okay. And then we got another score for there being like a lot of veterans. Okay, so what we want to do is like kind of combine those two ideas. So let's say we wanted to, you know, consider the number of veterans percentage and the age, the average age. You could weight them equally and you could just add them up and then divide by 2 because there's 2 scores. So let's do that here. Equals this thing plus this other score. So you add the 2 scores together. Actually, we should put those in parentheses. And then we're going to divide by 2. Oh, that's a pretty high score. And then I can take that and scroll it down. Or these shouldn't be there. So here's my formula. It's the first score plus the second score divided by 2. Oops, I went a little too far. That's okay. This would be a good time to invest in a mouse. Ooh. Oh, I just went too far. Here we go. All right, cool. So yeah, I got the average equally. Oh. There you go. Okay, and let's see who's the winner now. If I do the total score, I average them. The highest score is a 55, is Fadesville. Okay, followed by Clarksville and Jacksonville. Okay. You know, if we wanted to, delete this part here. Let's say that we think it'd be nice to have more veterans around us here, but like maybe our major issues, we want to hang out with people, you know, around 30. You can actually weight this more. You just use that score like several times. So like say I wanted to, this was twice as important as whether or not there's female veterans there. So what you can do is you can do equals, and I can add 2 of these. This is the score for like how close to 30 they were. So I can do this plus another one of those. So I can add 2 of those together and then add 1 of these. Oops, you know what? I think I did this wrong. Sorry. I didn't scroll all the way up. So let's say I want to do the age part twice. Equals, oh, you can also put it in here. Equals this thing, F5 plus another F5 plus 1 of the other scores. Okay, put parentheses around those. Okay, and then you can divide it by, since I have 3 scores now, I get to divide by 3. There you go. And I can scroll that down, and let's see if that changes anything. Okay, I got a little bit extra space there. I scrolled a little bit too far. So if I go to the very top, I can sort this. I don't know if that's going to change anything, but maybe. Okay, now the highest one is Clarksville, Fayetteville. Okay, it's the highest. And then you could, sorry, that's that one. This was the new one. Okay, so it looks like Clarksville and Fayetteville are still the highest. And you could change the weighting, but you can see that the scores are different. Okay.